VUX world. VUX world.
VUX world.
VUX world. Branding with the big faces.
I love listening to it.
Here we are, day 5 in the Big Brother house, and I've still got an accent. And we're not quite crazy yet, Dustin. Are you going a bit crazy yet or not?
I'm going a little stir crazy, but I'm not going crazy that I know of. Yeah.
Not crazy just yet. Fair enough. Catherine, are you crazy just now or not?
Not at the moment yet. We've been working from home for quite a while, so the reality hasn't quite changed yet.
Yeah, Joe Wicks is keeping you sane by the sounds of things.
Gets us up and active first thing in the morning.
He's taking YouTube by storm. I'm starting to think that maybe I should do like an evening workout live broadcast on YouTube and see if we can compete with some of that attention he's getting. Well, Catherine Breslin, welcome to VUX World. It is an absolute
Hi, thanks
pleasure.
for having me.
Yeah, it's an absolute pleasure. We met at Project Voice, and we've had Jeff Adams on the podcast previously. He was talking about the whole Amazon Alexa story and spoke incredibly fondly of you after we did the recording, and definitely recommended you as a certain guest that we should definitely have. So thank you very much for making the time.
No, our pleasure. I'm glad you got the chance to talk with Jeff because he's got some great stories.
He has his Dustin. What was that story about the whole kind of like blackout? Jeff, what's he called? What's the Jeff Bezos kind of like locked them in a room and kind of like made them turn off all the phones, swore them to secrecy, and
right.
revealed the grand plans for the Echo. Mad. So you work with Jeff at Amazon, is that right? Is that where you met?
Very briefly, Jeff hired me to Amazon, and then just after I joined, he left to found Cobalt Speech, which is where we both work now.
So for those that didn't see the episode, or listen to rather the episode, I'm getting used to this video. For those that didn't listen to the episode with Jeff and don't really know about Cobalt, tell us a little bit about Cobalt Speech and what you do over there.
So Cobalt Speech, our mission is to bring speech and language technology to companies, businesses who want to use it in their products and services. So we build anything you can think of speech and language related. We have our own speech recognition technology, our conversational AI, our voice interface technology. We do other technology as well, so text to speech, the output voice of these systems. We can understand things from audio signals, so think about a task like diarization, which is who spoke when in an audio stream. So we work on all these kind of adjacent technologies as well, and we combine them together in various different ways depending on what our customers are looking for.
So when we spoke to Jeff, because we were talking a lot about voice assistants, basically, we were talking a lot about Alexa, and my sort of initial understanding was that Cobalt Speech essentially builds bespoke voice assistants for people, which I'm assuming you do. But it sounds as though, from what you were just explaining there, you also break down the whole stack and provide services right along that whole process for any kind of speech technology that's needed anywhere almost.
We do, yeah. So voice assistants, people are very interested in how to take the technology and make it work for their application in their scenario. So we've seen a lot of interest in this, but we can use that underlying technology in many different ways. And we see a lot of clients who come to us with very different interesting requirements, different services they want to make, different technology they want to build.
Cool, fair enough. And what were you doing at Amazon? You were on the speech. Were you in Jeff's team? Were you in the speech team or not?
Yeah, so when I joined Amazon, I worked on the speech team. I worked on different speech recognition products. I worked on Alexa, and not just on the voice side of it, but also the language understanding too.
Okay, fair enough. So you kind of worked across a lot of the whole kind of pipeline kind of thing.
Yeah, some more of the pipeline of Alexa and different bits behind the scenes.
Yeah. And what were you doing before then?
So before I joined Amazon, I was doing a lot of academic research. So I worked at Cambridge University and at Toshiba's research lab here in Cambridge, where we did more academic research into improving speech recognition, making the technology better and more robust.
Cool. So would you class yourself as a techie? Are you a kind of like a coder, or are you more on the research side, or what kind of where would you put yourself?
I do a bit of everything. I've you can't get away from coding if you're doing research in this area. They overlap quite a lot. So I spend a lot of time in my life coding. I don't do so much coding at the moment. And now I do a little bit more talking with our customers and figuring out what they need. But sometimes I get a bit bored and get back into the coding every so often. Keep up to date with what's going on.
So it sounds like you've done nothing but speech recognition in your whole educational, professional career. What got you into that in the first place?
So I went to university and I studied engineering, and I had no idea what it was I wanted to do, but I kind of discovered that I really enjoyed the computing side of things and programming computers. But just programming computers, I didn't really just want to get into programming. And then in my final year of studies, being an engineering student, we discovered machine learning and machine intelligence technology. So this was way back, early 2000s, when technology wasn't as advanced as it is now. But that was really interesting, like this question of how do you get computers to do things which humans find really easy, like looking and hearing and talking. So I sort of followed that path and ended up studying a master's and a PhD in speech technology, and just carried on going, basically.
Wow. So we'll get into speech recognition in a minute, but first, as someone who is like, you are well into this whole industry from a point of view that very few people are, in terms of working within Amazon on the inside. You're now at Cobalt creating voice assistants for companies, and you're working right close to the technology that's making this happen, rather than kind of other people who are kind of using the outputs of the kind of stuff that you do to configure things. So the kind of like, well, and this is maybe we don't usually ask these kind of questions on the podcast, but I'm interested, given your kind of experience, what you think about this. There's the whole kind of concept of computers or robots or AI getting more and more kind of sentient and kind of like conscious, or whatever it might be, being able to govern itself, make its own decisions. From someone who's worked close to the technology, do you conspire to that worldview that is the way that this stuff is going, or is it more kind of like trying to get a Reliant Robin to race a Ferrari, which is just like never going to happen?
I don't think we're on the path with current deep learning technology to take us towards sentient computing. I think there are plenty of great things that artificial intelligence and machine learning can do right now, which are very narrow kind of tasks, but they can often do them faster and more repeatably and more reliably than people can. Some of the applications of machine learning, but then some of the applications are not well served by current artificial intelligence and machine learning applications. So I think there's a long way to go before we approach anything like human intelligence in a computer. And I'm not even sure that that's the path we're on. I think commercially the drivers are to make computers take away some of the boring tasks from people. So I like to think of computers working alongside people to sort of augment and help them do things better, rather than to replace them.
What are some of the most common misunderstandings that you hear when it relates to the work you do in machine learning and speech recognition?
I think there has been a lot of interest, a lot of public interest in machine learning and artificial intelligence. So the media talks about artificial intelligence, and a lot of the advances that they're talking about are reliant on machine learning, which is a particular subfield of computing, which is about learning things from data, learning patterns from data. So sort of machine learning and artificial intelligence are often the same, referring to the same kind of thing. And because there's such a lot of media interest in the topic, there's a lot of things that get reported, a lot of things that get tried, which aren't necessarily well understood. So I think there's a oversimplification sometimes in the media and public perception of what the technology can do and what it's capable of. So let's take speech recognition as an example, because it's what I'm really familiar with. We have great speech recognition systems that work for example, US, UK English. If you're talking about two people talking in a nice quiet room and they're having a civilized conversation between the two of them, so they're speaking clearly on general topics, our speech recognition systems there are great. But speech recognition systems fall down in various different ways when you have background noise, or people are talking over each other, or they're talking about a very specific topic where the language is different, or if they are speaking very heavily accented. But the perception is that speech recognition technology is really great. So I think there's a gap between what the technology is capable of and what people think it's capable of. That's one of the most common misconceptions I see. And you can see that across lots of different applications of machine learning too.
Did you see the thing? I've just been trying to find it. I can't find it yet, but I will find it and I'll stick it in the show notes. There was something around how it was only in the last week or so that speech recognition systems from some of the main providers tend to work better if you are American and white and male versus if you are, you know, not American, maybe black and female. But essentially what it was saying is essentially for black people, the recognition is not as good, but for white people there is, and that may be because there is inherent biases within the speech recognition systems. What are your kind of thoughts on that? Is that actually the case, or what?
That is actually the case. And I think this is a great example of how you talked about the idea of machines taking over. And I think that's a very becoming sentient and taking over is sometimes the narrative there. And that's a great sort of future worry, but there are worries about machine learning systems now. And one of those particular worries is that these systems are biased against particular groups of people. And this, I think, was first talked about in the context of computer vision, where face recognition systems performed much better on sort of white male subset of the population than it did on other ethnicities. And so there really is a problem that how we train our machine learning systems doesn't always work for everybody in the population. And machine learning systems are very reliant on, firstly, there's the data that you use to train it on. So to build a speech recognition system, you collect a corpus of maybe 1,000, 2,000 upwards hours of data, audio data, and you train your system on that data. Now, if that data doesn't capture speech patterns from particular accents or particular ethnicities or particular other subsets, then you don't learn as well how those people perform, how those people speak. And so you work less well on that group of people than you do on the group of people that you have well represented in your training data. And so that, combined with some of the choices that you make, other choices you make when you're building the system, can lead to these systems sort of not working for particular segments of the population.
Most of our listeners are more on the practitioner side. They're not going to be doing the research and the advancement of the technology that you're doing. So with that knowledge that they have about how this impacts, you know, different groups differently, how it performs for different groups differently, is there anything they can do to overcome that or try to smooth that out?
No.
I think just knowing is a great step towards being able to fix it. So like I said, a big part of the problem is to do with the data. And collecting data is a sensitive and difficult question in itself. So how do you ethically collect data from different groups of people to be able to train your system? But if we can work towards a world where people have better access to this technology so that we have a broader range of people using it, then that feeds back into some of these feedback loops that different companies have set up to sort of improve the system. And at the same time, just talking about these problems, making people aware of them so that the designers of these systems are aware and make steps to counteract that, then that's another good action.
Are your likes of Cobalt or Amazon, Google, Apple, etc., obviously are constantly working on improving the speech recognition?
Yeah.
And probably one of the ways that would be a good way of doing that is to review or listen to or capture the recordings of people using the system. So whenever I speak to Alexa, it will, you know, maybe those are reviewed or whatever I say gets funneled in to train the model, etc. That's probably one of the ways that you might be able to get hold of the data, I'm assuming, first party kind of data on this. But the question would be, is that how you would improve the system, the speech recognition system for different ethnicities, etc.? And if so, how would you actually tell by the audio that you're getting, because obviously when you create an Amazon account, you're not going to say that you're from Mexico and that you're a 50-year-old male or whatever, so how do you actually get this stuff better?
So I think there was some attention in the news maybe this time last year about the practices of different big companies around doing this, and I can't speak for any of them because I no longer work for any of the big companies, but collecting data, having people listen to it and transcribe it, and then feeding that back into the training of the speech recognition systems and the other systems that are in place as well, is a really obvious way to improve the systems. And machine learning systems work best on realistic data. So if you have actual data from people in the field, that's the best kind of data to make these systems better overall. But there is criticism of the companies that they're not transparent about their practices in this area. And I think some people feel that having them talking to these devices in their home and then having other people review it is something that they didn't sign up for. So there is some considerations around privacy and security to bring into play here. Some of the companies changed their practices in relation to that pressure last year. And some of them give options. Either they've stopped listening to data and have decided to start relying on other ways of collecting data, or they are giving you many more options to opt in and out of data collection for improvement. So there's different ways that companies are reacting to that, but it is that kind of data that you get in the field is unfortunately the best kind of data for making these systems better.
So we've kind of gone on to some topical situations there, which I think has been really good. But for those people listening who are familiar with voice assistants and they know the term speech recognition, I know the term speech recognition, kind of think I know what it is, don't really know the details of how it works and probably what it really is. So moving the conversation on, can you just, it'd be nice to hear how you would describe what speech recognition actually is.
Yeah, sure. So speech recognition is the task of taking audio data and making a best guess or an informed guess or an informed estimate of the speech, the transcript, the words that people said. So it's audio in and text out. Now, in order to do that, there's a few things that you need to put into the models behind the scenes. So our current speech recognition systems, most of what people have deployed follow a similar kind of pattern where you break the speech recognition down into 3 different modules or 3 different components. The first of those is the lexicon. So the lexicon is a list of words, and alongside each of those words, it has a phonetic pronunciation. So that's where you learn that the word cat maybe is pronounced k-at in the phonetic pronunciation, and the word that is th-at. And you have a long list, and this contains where you have multiple pronunciations of a word, so the and the, or either and either. All of these are contained in the lexicon. And you typically have, for English, around about 50 different phonemes, 50 different sounds that you combine together to make the words. And this is often sort of handcrafted by expert phoneticians in this lexicon. So from the lexicon, the next thing that you need to understand is when people talk, which sounds are they making? So you have something called an acoustic model. And this is taking small bits of audio and predicting which of those phonemes people are saying at the same time. So your model will take in a small bit of sound and say, well, I think the person is saying ah, and another small bit of sound, and I think they're saying ka. And then the final piece of this is called a language model. And the language model predicts which sequences of words are more common than others. So can you hear the kids in the background? There's the joy of...
I thought that we were going to hear man at some point. He's been screaming, just very faintly behind me. He's been screaming, he's teething, and yeah, he's been going crazy. So I think it's totally acceptable in this day and age. We're working from home and being on lockdown. Everyone's kids are going absolutely mental.
Yeah, I've seen all these things on Twitter about you know, how people should keep their kids off Zoom, and there was a New York Times article, and I think that's It's just not the way we could do things right now.
No. Did you see the one a while back with it was a guy giving a news report, and he was like literally just like in his room, he was giving a news report. It was live on like BBC or something like that, and his kid just comes walking through the door and walks us through like that.
Oh, that was brilliant. I think that was the first time we saw the reality of home working on such a large scale. Great. So let me get back to the language model.
The language model
that I was talking about. So the language model is the final bit of the speech recognition system, which is going to tell you which sequences of words are more likely. So if I say the cat sat on the, I know that the word mat is probably quite common, but also there are other things that are common, like chair, rug. All of these would be quite common. Whereas the cat sat on the goodbye, it's not going to happen really. So this language model is going to tell you about the sequences of words. So we put them together. We've got an acoustic model, which tells you which sounds are being spoken. The lexicon tells you how those sounds combine into words. And then the language model tells you how those words combine into sequences of words. Put them together in a decoding algorithm, and we have a speech recognition system.
Wow. So how then, and this might be all part of the wizardry, but when an audio signal is fed into this system, how does it actually recognize which bits of the audio match to which like phoneme or lexicon? Like how can it tell? Because all audio is just frequencies, isn't it?
Yeah.
Basically. So how does it actually tell what the audio is, that it's even speech in the first place? Like, is it all to do with like frequency recognition?
It's all to do with the frequencies that are in it. So if you record an audio file, you can look at it in a different view. You can look at it in a frequency view, and then you can see quite clearly the different characteristics of different phonemes. So there are some, they fall into different groups. So you have vowels, for example, like R, E, U. They have got very strong characteristics of frequency. So they have a fundamental frequency, and then different frequencies above that are active or not. So you can see the difference between the different vowels just by which frequencies are strong in it. Something like a k or a p, these are what we call plosive consonants. So they're sort of quite bursty. They have very different frequency characteristics to those vowels. There are other things like sh and s, which are a little bit more like noise. So they've got a constant frequency response. So if you look at the frequencies that are in those, like white noise is kind of a s sound. And so you can see that there's different, across all the frequencies, it's relatively even in those sorts of sounds. So you can tell them apart just by looking at the different frequency components that occur in the different signals.
And is that, so that presumably the signal that is inputted, first of all, needs to be decent in the first place for anything to even work in the first place. Is that right?
So we can work a little bit in noise and reduced audio quality scenarios, but the higher the quality of the audio, the better the speech recognition is going to work.
Okay. So once we have an audio signal, we break that audio signal down into a frequency spectrum, and we use the frequencies that exist to map each phoneme throughout the audio signal. Is that right?
Yeah, so if you think about this in a little bit more detail, we take the audio signal, which might be, say, 5 seconds of audio. We break it down into small, typically about 25 millisecond frames. So for each frame, we're going to predict a phoneme. So we take that 25 millisecond audio, and we have actually trained a deep neural network, a machine learned model, which is going to take the frequencies in that 25 milliseconds, the frequency response, and figure out which sounds it thinks are most likely. And then you move along to the next 25 milliseconds. And again, you take the frequencies and then you look through a neural network and see what's predicted as the sound, and keep going through that whole 5 seconds.
Wow. So that sounds like some fairly fast computing. So it needs to
Yeah,
be done.
it's fairly fast computing. And these don't have to be like 100% accurate, and they actually aren't 100% accurate. But if you get the actual sound a little bit wrong, and you might say, I think this is an A with high priority, high probability, but an O with slightly lower. But the language model says an A doesn't make sense in this because I've got all this other information about the words that are being spoken. They sort of can help each other a little bit as well. In the same way that, you know, when you listen to somebody and initially you think they said something and then your brain corrects it later. I think that something similar goes on with all the information from the speech recognition system. So it can make mistakes in the language model or make mistakes in the acoustic model, and sometimes they can help to correct each other.
And then so you see some services in this domain, especially in, I think, the search domain, who don't even do this translation to phonemes, translation to text, and they're trying to match sort of audio to audio. Does that have any advantages or disadvantages, or when would you use one or the other?
So are you thinking about sort of speech-to-speech translation?
Yeah, or more, some of the companies that Kane and I have come across, they're trying to perform searching without doing that speech-to-text step, with just trying to match the sounds that are coming in with, I guess, the audio that they have that they're searching through. Is there any benefit to doing that?
Yeah, so this is another thing that we do as well as speech recognition. But in order to search through a set of video recordings, one way you might think about doing this is to do the speech recognition transcription of what's going on and search the transcription. Now that's fine, except that the transcription is going to make mistakes. And if you search for a term where it's made a mistake, you won't be able to find it. This can crop up, for example, I mean, we get new language and new words come into play all the time. And so suddenly a word might come into being which didn't exist when you ran the speech recognition system, but you want to search for it. And so a better way to search audio is to phonetically index a large corpus of videos so that you have a good idea of what sounds are being spoken at different times. And then when you want to search, you can take your search term, work out the phonemes in the term that you're searching for, and sort of do a fuzzy match with what you thought exists in the audio. So this is more likely to get you a bigger range of responses because you're not restricted to exactly what the speech recognition system has measured.
Interesting. So how much of your skill set, if you were working in this field as you have been, needs to be in understanding audio? Because this almost seems as though everything comes down basically to understand. That's all this is, isn't it? That's all speech recognition is. I'm just clicking in my head now. It's basically you're just trying to understand audio, aren't you?
Yeah, it's a lot of signal processing in there. I think in more recent years, we've used a lot of, there's been a lot more tools developed. So there's a lot of things you can run just to do the signal processing for you. So maybe you don't need to understand so much as before these tools all existed. There's also advances in the machine learning algorithms. So especially the introduction of deep learning, deep neural networks have meant that you don't need to do as much signal processing as well. So there's a move away from knowing so much of the signal processing, but fundamentally underneath, you need to understand a little bit about audio and how it works and what you're looking for in it. And the same as with all AI tasks, you need to have some knowledge of the domain and what's going on underneath to be able to know how to set up the algorithms, what you're looking for, how best to measure it, how to tell if it's working.
And then once you have, going back to what we were talking about, going through that pipeline, once you've got an audio signal, you've analyzed all of those frequencies, you've broken it down into 25 milliseconds, you've understood the frequencies that are in each millisecond, you've put that and matched that against a group of phonemes that you have already put into it. The phonemes then stack together to make words. So the phonemes then, are the phonemes sounds that you've stored?
Yeah, so they're things like
records, basically.
Yeah, like a and k and th. those sounds which make up the words that we speak.
So the match then is you take the 25 milliseconds, you analyze the frequencies, you figure out based on matching the frequencies that you've got stored in your lexicon, did you call it?
Yeah. So the lexicon is about the pronunciations of the words, so how they are said, how the sounds go together to make the different words.
Okay. So each 25 milliseconds, I just want to make sure I'm understanding this.
Yeah,
Right,
yeah.
So we've got it. So each 25 milliseconds of audio is analyzed for its frequencies.
Yeah.
Those frequencies are then matched to a phoneme, and then the phonemes stack together. And at that point in time, all you have is just a series of phonemes, a series of sounds, and a series of frequencies. And
yeah.
then presumably your language, was it a language model you'd said?
Yeah, so there's the language model, which is combining all the words together to make sequences of words, and the lexicon. So it's a little bit more, we don't do them it's not a pipeline where you do the acoustic model and then the lexicon and then the language model. They're combined together in a search algorithm we call decoding. They're sort of used in parallel. So the language model says, well, I know that if I've heard so far the cat said on the, and then you hear the sound m, the language model tells me I should look at the word mat, but I probably shouldn't look at the word model. So it sort of helps you figure out how to decode as you go along. So it's a sort of, using them all together at the same time to figure out where to look next to figure out what was being said.
Okay. So after, I must say after, and even though you've just said it's not a linear process. So the language model then is that just a huge corpus of every word possible to imagine in the dictionary, or is that a whole load of different sentences, or is it like what actually is the language?
So the language model, we train it on text data, so nothing to do with audio in the language model. Take a large corpus of text data, and one of the still most common ways to do this is to count how often words and short sequences of words appear. So we can count that, for example, that the word the and the word and are very common in English, or the cat is quite a common phrase, or the cat sat is a common phrase. But there are other phrases which wouldn't appear so often, like hello, goodbye, tomorrow. That's unlikely to appear together. And so we sort of just count how often these things appear and use that information.
Right. So the language model is text based, and it is able to, through analyzing tons and tons and tons of text, can then start to predict which words should follow one another.
Exactly.
And
these are trained on, say, millions or billions sometimes of words. And there are in other fields, NLP itself has made huge advances in language modeling lately, and it has some very interesting language models that are being built based on neural networks and sourced but in speech recognition, because you have to use it in the runtime system. The counting statistical approach is still very common.
So I suppose the bit that we've presumably missed, unless I've misheard, we've done the audio analysis, the frequency analysis, the phonemes stacking together.
Yeah.
We now understand what the language model is and how that works. How then does this load of frequencies mashed together into a sequence of phonemes end up as text?
So this is how we use the lexicon in the middle. So the lexicon tells you that different series of phonemes make particular words. So we know how the phonemes k, at combine to make the word cat.
Right.
And the phonemes th, or the e combine together to make the word the or the.
Right. So then that audio is then, the lexicon the thing that transcribes the text?
So the lexicon is telling you how to combine those sounds to make words, and if you can figure out what words are likely, you can use the language model to say whether they're probable or not, and you end up figuring out a best guess. So all of this is statistical, so it's estimating what's the most likely sequence of words to have come out of the audio in total.
So speech to text isn't necessarily a literal transcription of what it has heard. It is a statistical prediction of what it thinks it's heard.
Exactly, yeah. And that's the best way we know to do it at the moment, because if you listen to audio and you try and write down example rules of how to convert that into words, you'd be there forever trying to write down everything. It would be really difficult, and we can't get the knowledge about how we understand speech from our brains into computer code that we can use very easily. So sort of we just learn to do it from examples of audio and examples of text.
Right.
Yeah, I think one of the things that at least I visualize it, and Catherine, tell me if I have this correct, is it's similar to what we do as well. You know, when we learn a new language, a lot of times we struggle with listening because we don't know what something should be in a certain place. We don't have that experience enough to go, okay, actually, you know, I couldn't quite hear Kane, but you know, this is probably what's going on.
Yep.
I think a lot of people are probably noticing this week, where your Zoom or your Hangouts will disconnect for a little bit, but you still get the gist of it. Because you can understand what's happening. Is that sort of the same thing, where if I say, you know, let's have a cat or chat next week, then we can figure out?
Yeah, and I think that's a great example of when the video sort of gets a bit glitchy, but sometimes you can still understand what people are trying to say, and because you have all this knowledge about the things that they're likely to be saying, and not just because you know English, but also because you know them and you know the context and you know the topic that you're talking about.
On that note, you mentioned not just the language, but also the context. So when you're working with clients, how much of the work is going towards fine-tuning based on their specific vertical, their context, the actual application that you're building?
So we actually do an awful lot of that. So our main mission is to help build speech recognition systems and language understanding and voice assistance, any voice and language technology for specific scenarios. And so a lot of the work we do is figuring out how to make something that works okay in a general situation work really well for a specific client, because we can learn about what it is they're trying to use it for. So if you have a speech recognition system or a virtual assistant that you are putting to control a machine in a factory, you're never going to ask it what's the weather or play some music. So you could use some information about what it's expected to do to help improve its performance there.
So why, I get that in certain situations you're not going to ask something for the, like, if I don't know, if I'm I don't know, a delivery driver with an earpiece and I'm doing my work by just talking, yeah, number 38 delivered that one, you know, whatever, I might not ask it the weather. But is there anything specific about certain, or what is it actually about certain domains that require their own speech recognition? Why isn't the general speech recognition system good enough?
I think there's various different scenarios, and often a general speech recognition system can work perfectly well. But if you think about, maybe we go back to that factory, there's a lot of particular background noise that's very specific. If we know about that, we can maybe train our acoustic models to be able to understand that noise a bit better. Or if we have, we did some work recently where we were looking at chemistry lectures on YouTube and trying to transcribe them. And chemistry has lots of very specific vocabulary in, which in a general speech recognition system is very unlikely to be spoken in a general scenario. And so we found that by tuning our speech recognition system towards chemistry lectures, we could do much better. So there's to do with, I guess, the subject and the vocabulary and the language that people are using, and then also the acoustic environment that it's happening in. Those are two really common use cases for like tuning a custom system.
Regarding the acoustic environment, so let's go back to the factory floor example. Would you go and actually take audio samples on that factory floor, or are there other things you do to tune that understanding?
So there's a bunch of things we can try. The absolute best thing to do is to get people talking to the system naturally on the factory floor, so we can get the natural speech. But that's often expensive and time-consuming and really difficult to do. Another thing we can do is we can go and just record background noise. So we can use that background noise to sort of add it into our clean audio and pseudo-generate with data augment. It's called data augmentation in the literature. Sort of augment the clean audio that we have with some noise to make it seem more noisy. That's not quite as good as actual live data. So one thing that people do when they're talking and they know it's noisy in the background is something called the Lombard effect, and they tend to make their speech much clearer. They emphasize different parts of it to overcome the noise. And so if you just take recorded noise and clean speech, you miss out on some of the things that actually happen in real speech. But it can get you much closer to what you actually need to train your speech recognition system. If we can't get actual factory floor noise, we could maybe find other sorts of noise sources and make our system more generally robust to noise, which would help. And the other thing we want to do is sort of figure out the language as well. So adapt the language to the situation. So we're much better at recognizing the specific things that people are going to say. So there's a number of different things we could do. Some are better than others, some are cheaper than others. So there's sometimes a little bit of a trade-off in how we go about doing things.
How will a company that has a requirement for kind of speech recognition, how are they supposed to understand whether they do need their own bespoke speech recognition system, or whether an off-the-shelf one will do? Is it because they try the off-the-shelf one, realize it's a load of rubbish, and then need to find a different solution? Or is there anything that you can advise if anyone's listening to this who might have a need for a speech recognition system? How will they be able to understand whether it's likely that they'll need a bespoke one or one tweaking versus being able to use the general one?
I think most people would do exactly what you suggest and sort of try out a few different systems and see how well they work for their scenario. You can record some sentences, try them through different systems, get a feel for how well they work, and go from there.
And what kind of applications? We spoke about voice assistants, so
Yeah.
obviously something with a voice interface requires a speech recognition system in there if you're on the factory floor or if you're doing the postal deliveries or whatever. What other kind of applications does this technology have? Is it all solely for voice interfaces, or is there anything else beyond that speech technology is being used for?
There's, I think, plenty of applications beyond voice assistants. So actually, one of the first ways I learned about speech recognition was dictation. So like 20 years ago, there was a Dragon Dictate was a big software package that let you dictate your audio, and it would write it into essentially a Word document for you. And so dictation is used in many different scenarios, either people who can't type at home because they can't access a keyboard, or they have other physical impairments that means they can't type. Or they're on the move, they don't have access, they're using their phone. A lot more people are just using it because it's more convenient to speak than it is to type on a little smartphone screen. And yeah, so dictation of documents is one that I think is really interesting, and it's seeing a bit more of an increased use now that there's smartphones. Video subtitling, another, which could be either sort of subtitling of a video that you've already created or live subtitling of broadcasts. These things we can start to work on now, so that other people can access can understand what's going on in the video. There's plenty of applications around. In some fields, some areas, you have to, there are certain legal obligations on people. So in financial services, for example, if you're advising people, there are certain things you have to say to them, certain disclaimers you have to make. The same with legal as well. So, or some other kinds of sales, you have to be sure that these things are said. And so you can use speech technology to help understand those financial services calls and be sure that your employees are saying the right things so that you're compliant with the law. And that can help speed things along and mean that not everybody has to sit and listen to all these calls afterwards to be sure that things are said. So sort of helping on compliance purposes. Another call centers, there's a lot of, we talked about voice assistants, but a lot of people are trying sort of more automated, at least in the first pass, more automated call centers, which use the same kind of technology as a virtual assistant, just on the end of a phone line. Another place where speech recognition is very interesting. And also in the call center, maybe not just automated voice interfaces, but sort of analyzing the sorts of problems that you're seeing people phone up about, so you can get analytics about the things that your customers are calling about, understand if there's something wrong because 20 customers have phoned you in the past hour about it. So I think there's lots of places where there are people talking where you want to understand more about what's going on in those conversations.
I like that you bring up the subtitles and captioning, because two of the most amazing speech related technologies that I've seen over the past year have been, I think, on that topic. The first one is I saw Google I/O last year that they are, I think, just in English now, but they can do live transcriptions of phone calls for hearing impaired people who can then type back their response. And then the second one was actually really useful, where I was giving a talk and I was giving it in English, but a lot of the people who were there at the talk didn't understand English. And in PowerPoint now, at least the latest PowerPoint on Windows, you can do live subtitles. So it will actually caption and then transcribe or translate as well. And so it sounds like a lot of the things that you're working on and adjacent to what you're working on as well are not just the assistance, but also just making life easier for people who otherwise couldn't access that stuff.
Yeah, and I think it's easy if you're healthy, white, British, to feel like you can understand everything that's going on in the world, or that you can hear everything well, or that you can see, and you sort of forget that some of these technologies are really changing people's lives because they make things much more accessible, and that's a great use of technology, I think.
Fantastic. Well, Catherine, that was probably the most interesting 45 minutes that I've probably ever experienced. I don't know if it was just me, but Dustin, has your mind been blown a little bit there as well?
I'm pretty blown.
That was fantastic. Catherine, where can people find out a little bit more about you? I know you've got a fantastic blog on the Cobalt website. We'll definitely link to that. But where can people go to learn a little bit more about what you're up to? How can they reach out to you if they need a bespoke speech recognition system?
So you're exactly right. We have a blog on the Cobalt site, and there you can find all the sorts of details to get in touch with us. We're on Twitter and LinkedIn. You can find us there.
Cool. This has been an absolute pleasure. And I think the video recording went all right, Dustin, on this situation?
Yeah, I think it did.
Yeah.
What do you think, Catherine?
I think so.
Yeah, I think we'll do this again. So thank you if you have been watching this. And as always, thank you for all those who've been listening on the podcast. We'll have another one coming next week. You can find all of the links to everything Catherine had been mentioning. And hopefully, now that we've been recording this video, a transcription of this conversation via Zoom as well on the show notes.
Fantastic.
Absolutely spot on. So yes, thank you all for joining us. And until next time, see you later.
VUX world. VUX world.
VUX world.
VUX world. Branding with the big faces.
I love listening to it.
Kane Sims.
Kane Sims. Kane Sims, the one and only.
Britain's finest, Mr. Kane Sims.
Dustin Coates.
I like it when you guys are together and talking about voice.
Without further ado,
Welcome to the show.